Welcome to Prince Expository YouTube channel. In this video, we will learn about how to draw displacement and cam profile for the uniform velocity follower motion with the combination of radial cam and knife edge follower. Let us look at the question related to the problem on uniform velocity with the combination of radial cam and knife edge follower. A cam is to give the following motion to a knife edge follower. Outstroke during 60 degrees of cam rotation, dwell for the next 30 degrees of cam rotation, return stroke during next 60 degrees of cam rotation, and dwell for the remaining 210 degrees of cam rotation. The stroke of the follower is 40 mm and the minimum radius of the cam is 50 mm. The follower moves with uniform velocity during both the outstroke and return strokes. Draw the profile of the cam when the axis of the follower passes through the axis of the camshaft and the axis of follower is offset by 20 mm from the axis of the camshaft. In this video, we will learn how to draw displacement and cam profile for a bit, that is the axis of the follower passes through the axis of the camshaft. Now let us look at how to solve the problem. For your presentation, first we need to copy down the given data and then the step 1 is to draw displacement diagram. Before drawing the displacement diagram, I would like to define what do you mean by this displacement diagram. This displacement diagram is drawn by taking angles of cam rotation on x-axis and follower displacement on y-axis. Angle of cam rotation, that means 360 degrees of cam rotation is divided into 4 segments, namely outstroke, dwell, return stroke, dwell. Another name for outstroke is rise. Another name for return stroke is return. In this way, in the question, the information will be given. So, outstroke 60 degrees, dwell 30 degrees, return stroke 60 degrees, and finally dwell to 10 degrees all together combine to form 360 degrees of the cam rotation. With this displacement diagram, we will come to know at which stroke the position of the follower is. The position of the follower is identified through this displacement diagram. Now let us first try to understand from the question. For drawing the displacement diagram, first of all we need stroke of the follower. In the question it was given 40 mm. So this 40 mm should be drawn vertically and 40 mm is indicated in this way. And because this 40 mm, the stroke of the follower is drawn as a vertical line, we represent y. And then a horizontal line is drawn connecting the bottom of this stroke of the follower. The reason being, we need to indicate all the strokes at different cam rotation. And how do we divide this outstroke, dwell, return, and finally dwell on this diagram is with the help of the angles, with the help of the angles of the cam rotation. So how it helps us in the sense, say for example, we will now consider a scale for constructing this displacement diagram. What is that scale? what for the scale is meant for in the sense angles of rotation should be converted in the form of centimeters. Let us say, for example, 10 degrees is equal to 1 centimeter. Taking that, say, for example, a standard scale, now we will convert 60 degrees, 30 degrees, and 210 degrees into centimeters. When we take 10 degrees is equal to 1 centimeter, 60 degrees will become 6 centimeters. 30 degrees will become 3 centimeters. 210 degrees will become 21 centimeters. Suppose if even we consider 10 degrees is equal to 1 centimeter, on conversion, if it doesn't allow the diagram to be on the page, we can go for a reduced scale. Like say for example, 10 degrees is equal to 0.5 centimeters. You can go in that way according to your convenience. After considering the scale, converting these angles of cam rotation into centimeters, now we will indicate them representing different segments. So 60 degrees of cam rotation is indicated first as outstroke and indicated dwell immediately on this, and with the scale return stroke is indicated, and finally dwell to 10 degrees also indicated. In this way, angles of rotation representing the strokes are mentioned in the form of the divisions. Now, outstroke and return stroke are the major things to be taken into consideration. The reason being, the follower moves with uniform velocity during both outstroke and return stroke as mentioned in the question. The follower moves with uniform velocity during both outstroke and return strokes. Thereby, our main concentration is on outstroke and return stroke. Now, this outstroke is now divided into n number of equal even parts. Similarly, a return stroke also should be divided into n number of equal even parts. Let us go for the division of outstroke now. You see, the division of outstroke is divided into 6. Similarly, return stroke also will be divided in that way. Why we need to undergo these divisions is because of to have a clear points of the profile of the cam. More number of divisions will give you the accurate cam profile, less number will give you a reduced accuracy form. Now, the next thing is keeping follower moves with uniform velocity during both the outstroke and return strokes. Now observe very carefully. We will join this point A and we will join the starting portion of the dwell. Before joining, we have to give the numbers of the divisions 0 to 6 for in the outstroke division, 0 dash to 6 dash in return stroke division. Now join this A or 0 to the beginning of the dwell. This represents uniform velocity. That means the follower on rotation of the cam, then the follower advances upwards and reaches to the maximum height. Then what happens during the next dwell period? Cam rotates further 30 degrees, but it was observed that there is no follower motion. That is the reason we call it as dwell. And at the later point of time, still further the cam rotates at 60 degrees, and it was found to be there is a uniform return of the cam. Thereby, what happens? Uniform return of the follower is observed. And finally, for the remaining 210 degrees, the follower remains in dwell. So the pink color line represents this displacement diagram of the particular combination. So why we are drawing these straight lines during outstroke and return stroke is because of the uniform velocity. The follower rises up with uniform velocity and descends down with uniform velocity. That is the reason we will be drawing these lines in a linear way. Now, the pink color line intersects the divisions at various points. Now you can see the pink color line intersects the divisions at various points in both outstroke and return stroke diagram representation. So we are now taking those points into consideration and then we will give them the alphabetical representation. The intersecting points of the pink color line with the divisions of blue color will be taken into considerations and will be given alphabetical representation both in outstroke as well as in the return stroke. In this way, we will complete the displacement diagram and then we will use this displacement diagram for drawing the cam profile. Now, let us look at the first bit. Draw the profile of the cam when the axis of the follower passes through the axis of the camshaft. Now, observe very carefully. The first and the foremost thing is we require this displacement diagram for drawing the cam profile. And the second thing is given in the question, a base circle radius of the cam is 50 mm. Then immediately the first step is to draw the circle of radius 50 mm and name it as base circle. And then because we are solving problem first bit, the axis of the follower passes through the axis of the cam. So that is the reason, as according to the question, the follower is made to be in contact with the base circle in such a way that both axes are in coincidence or in line. So this represents the first bit position. And then we have outstroke 60 degrees, dwell 30 degrees, return stroke 60 degrees, and finally dwell 210 degrees. We will represent these angles on this base circle starting from this end. This is the starting position where we will indicate 60 degrees now. Now let us move on. Now observe very carefully. So measure from this line 60 degrees which belongs to the outstroke and just draw a line. And then followed by 30 degrees dwell, followed by 60 degrees return stroke, and the remaining will be the remaining from this last line of this return stroke and up to the first line is 20 to 10 degrees. Now, after dividing, here also our main concentration is on outstroke 60 degrees and return stroke 60 degrees. So, let us divide this 60 degrees into 6 divisions. So, now you can see 6 divisions, equal divisions, and then whatever may be the extended divisions, those will intersect on the base circle. Then starting from 0, we will number them 1, 2, 3, 4, 5, 6 as observed in the outstroke of the displacement diagram. Now it was numbered. And then what we are supposed to do is to observe very carefully from the displacement diagram, particularly outstroke, the starting of the cycle. A and O are having having the same contact. Here also A and O are having the same contact, same point. Now look at the displacement diagram. Here we have the combination 1b distance. So with 1, measure this 1b and cut an arc on 1 so that that point will become B. Similarly, 2c distance, 3d, 4e, 5f and 6g. So with these distances, we will cut an arc so that we will be getting A, B, C, D, E, F and G. From where we will cut an arc, in the sense from 0, 1, 2, 3, 4, 5, 6, we will locate the points, all these alphabets up to H. So similarly, a return stroke also should be divided into equal divisions as divided in displacement diagram. Now you see the divisions of the return stroke. Now these divided lines will intersect the base circle at certain points. We will give them the numbering as given in displacement diagram: 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. So after given the numbering, now similar to that of the outstroke, now we have to locate remaining alphabets from numericals. 0 dash to H is the distance, 1 dash to J, 2 dash to K, 3 dash to L, 4 dash to M, 5 dash to N, and 6 dash and P are having the same point. So cut an arc and indicate the alphabets. And we are at the final end of drawing the cam profile. Now you see, my dear students, starting from A, join A, B, C, D, E, F, G, H, J, K, L, M, N, P. And this remaining part also you have to dark it very carefully, and this is going to become the cam profile. In this way, we have to draw the cam profile for the uniform velocity follower motion with the combination of knife edge follower and radial cam. In the next video, we will look at the axis of the follower is having an offset with the axis of the cam.